Greetings, wonderful Physics 111 students, and welcome to Physics with Captain Rod here. So I'm making this video to help you out with the first probably 5 homework problems we're going to talk about. So the first problem here, these are all unit conversions. So I'm going to talk about what this should look like. Whoops. Scroll down a little bit. I'm just going to pick one of these. And let's talk about, we'll talk about this one right here. So if we want to convert from feet to miles, the first thing you have to do is look up a conversion factor. So if you look this up, I think you're going to find there are 5,280 feet in 1 mile. So the way you do our conversion here, you start with a 25,000 feet. Make sure you write out the units, and anytime you're converting units, you are multiplying by a fraction. That fraction needs to be equal to 1. And it needs to have units that leaves you with what you want and gets rid of what you don't want. So if I write 1 mile over 5,280 feet, because these are equal, this fraction right here is effectively equal to 1. So I haven't changed anything. And you'll notice that the units cancel, leaving us with miles. And then you just do the multiplication. 25,000 times 1 divided by 5,280. You will get some number, which is now in feet. So repeat for all of these. But that's what that work should look like. And make sure you show all work for full credit. What I want to see mainly is this, showing how the units cancel. Okay. Number 2, draw each vector on the right, express it in unit vector form. So I'll get you started with this. All right, a vector 10 units long at 30 degrees. So I'm going to put a little coordinate system here, x, y. Unless told otherwise, angles are measured with respect to the positive x-axis with counterclockwise positive. So this vector right here points something like this. Okay. 10 units long, and there's the 30-degree angle. And counterclockwise is considered positive. Now, express it in unit vector form. So if you were to draw that vector's components, and I'll do this in red, the x component, whoops, did I say red? There we go. The x component is here, y component here, and I'm just going to temporarily give those names. If I call this vector A, I would call this guy AX and AY. Now, this is adjacent to the 30 degrees, so it can be found with the cosine function. And if you go through and do that, you should get 8.66 for this. I'm not going to do all the work for you. But you write out cosine 30 would equal AX over 10. Right? This one will work out to 5. You're going to get that from the sine function. Sine 30 degrees is equal to AY over 10. So this vector A can be written 8.66 to the right, or in other words 8.66I, and then 5 up. And the math way of saying that here is 5J. So repeat for these problems. I'll give you a little clue here. So 150 degrees, when you draw that, right, you put a little coordinate system in. Whoops. I'll just leave it right. Oh, there it goes. There it changed. All right. So you're measuring with respect to the positive x-axis. That's 0. Counterclockwise positive. So 150 degrees puts you in quadrant 2. Then you draw your vector. Now, how long you draw this doesn't really matter because you're kind of free to set your own scale. So that's how you draw the vector. Then draw its components, which will look something like this. I would probably use this angle. Should be pretty easy to figure out what that angle is. Then use your basic right angle trig to find this, and then express that vector in unit vector form. All right. That should get you through that set of problems, hopefully. Contact me if you're having trouble. Number 3, draw and find the components of each vector shown and write each one in unit vector form. So I'll go ahead and get one of these going for you. I'm just going to pick one here. I'll talk about C. All right, so vector C is 12 units long at negative 60 degrees, or you could say 60 degrees clockwise from the positive x-axis. To draw its components, one way to do that might look something like this. I would call that Cx, Cy. Now, it doesn't really matter if you draw that like I did, like right and down. You could also go down and right, doesn't matter. But here's the things that do matter. This needs to make a right angle, and then this needs to end up at exactly the same place. Now it says find those components. So whatever vector C is, it can be written as Cx in the I direction. Let me put minus Cy in the J direction. The minus sign has already been taken into account. By the way, if you want, you could also put plus Cy in the minus J. These are equivalent. Now, what's left to do is find values for Cx and Cy. You can get those from right angle trigonometry. If I write this out, cosine of 60 degrees, that's my little shorthand for that, would equal Cx over 12, because Cx is adjacent to the 60 degree angle. Sine of 60 degrees is equal to Cy over 12, right? Because Cy is opposite the 60 degree angle. So basically now your answer is going to look like the vector C is equal to some number I minus some number J. You're getting those numbers here and here. And again, you could put plus a number in the minus J, like this, plus some number, and then put the minus sign with the J is just fine. Okay, repeat for all of these problems. Okay, find the magnitude and direction for each vector addition below. So A plus B. So what you want to do, all right, and keep in mind from up above, you will have already found each vector in unit vector form. So if I draw the vector components for A, there's AX, there's AY. These you should have found in the previous problem, because the previous problem said to express all these vectors in unit vector form. Vector B, right, there's your X component, there's your Y component. Does not matter if we draw this like right and over, or we could have went like this, up and over. All right, again, I can draw this right and then up, or up and then over. It doesn't matter. Just what does matter is make sure you end up with a right triangle. All right, now when you do your vector addition, I think the first one was A plus B. The big thing about vectors is you add them by adding components. You're going to add this number to this number. Right, you're going to get something in the I direction. So it'll look like something I plus, and then you'll have this plus this in the J direction. You'll end up with some number there in the J direction. Now, in the first example, A and B here both had positive X and Y components. Just keep in mind when you have to take direction into account when you look into some of these other examples. So, whoops. Let's see. So when you do D plus B, right, that's these two. D has a positive Y component but a negative X component. Make sure you take that into account when you add those vectors up. Right, you always have to take direction into account. Okay, number 5, consider the following vectors. Sketch them tip to tail, eyeball their relative magnitude. I will get you started on this, okay? Let's start with the first vector. Oops. Okay, 100 units at 50 degrees. So, maybe start here, put a little coordinate system, x, y. 100 at 50 degrees. Now 50 degrees measured from the positive x-axis maybe looks something like this, where this would be the 50-degree angle between the 0 and the positive x-axis. Basically, when you're doing these sketches, you can kind of, for lack of a better way to put it, eyeball how long. You're free to choose the length of this vector. Now, when you do that, you have effectively set a scale now. This is 100, so 200 would be roughly like that. 50 would be roughly like that, right? So then once you set a scale, you just kind of try to honor it. All right, now we're going to draw the second vector here, and here's the key. You start here. So imagine, and you can even draw it if you want, put a little coordinate system in, like a little XY. Now go to 90 degrees and draw a vector 50 units long. 50 units long should be half the length of this one. Once you draw that, then you can draw the resultant and make darn sure your resultant starts here and ends at your endpoint. Okay, now, next, where it says find the resultant in unit vector form. Take the two vectors, vector A and vector B, and write them in unit vector form. So this one's going to look like something I plus something J. This one is basically done for you. Vector B, if it's at 90 degrees, I'll let you think about this. You know, what is the X component? All right, I'll just say it like that, and then it'll be a number in the Y direction, right? Then just add these by adding components. The next part, once you add these and you've got that our resultant vector is a number in the I direction plus a number in the J direction, you should be able to sketch this now. Start by just drawing the components, you know, something to the right, something up. Trying to keep relative magnitude in mind. Here's what I mean by that. For a quick example, if this were something like 2I plus 4J, then this sketch might look something like this. 2 to the right, 4 up would be about twice as long. There's your resultant vector. And then in my little made-up example, this would be 2, 4. You would then find this by Pythagorean theorem. And here's an angle. You would find that by the using the tangent function. So again, your values won't be 2 and 4. I'm just giving you an idea of what that would look like. So that's probably good enough for now. I think we've chatted about the first 5 problems. I'm just going to call that good at that video there, and probably make another one for the next 5. Hope that helps. Have a great day.